The Alldus podcast is brought to you by Alldus International, supplying your expert AI and digital transformation staffing needs across the US and Europe. Today, you are listening to our AI in Action series, where leading minds in AI from across the world share their story, success, and advice. AI in Action cuts through the hype and explores the true impact of artificial intelligence in our world today.
You're listening to AI in Action. I'm your host, JP Valentine. Our guest today is Maxime Gariel. Maxime is the Chief Technology Officer at Xwing. Maxime, welcome to the show.
Thanks, JP. Thanks for having me.
Oh, it's our pleasure. So, Maxime, very excited to learn all about Xwing, but let's start with yourself. Can you give us a brief background of your journey in technology, from where you got started, some of the roles you've held along the way, and take us up to today?
Sure. So it started back in France and during my undergrad, where I was doing aerospace engineering. At that point, I knew I loved airplanes. And then I did a one-year internship where I was designing autopilots and autoland for airliners. And that's when all the pieces came into my mind. At that point, okay, I know I love airplane, and now I know I love to make them fly themselves. So that was about 15 years ago, and my journey will be to make airplane autonomous. I came to the US, got my master's and PhD, focusing on flight controls, but also in air traffic management. And it is a very complex system where you orchestrate all of the flights in the country. And what happens when you put more and more automation into it, try to rely less and less on humans, and you put computers to be in charge of those flights or the organization. But what happens when some of the sensors start failing? So what is the plan B, the plan C that you need to have to make sure that the safety of those flights is always ensured? Then I went to MIT for a postdoc where I was looking at traffic collision avoidance for small airplanes. And that led me to Rockwell Collins, where I was working to convert manned helicopters into fully unmanned helicopters. So adding all the sensors, adding the computers, the algorithms to make these helicopters fly themselves. And one of my projects, we took this 1.8 metric ton helicopter and made it convert into a fully automated helicopter that could take off, navigate, land, and even auto-rotate. So if it lost the engine, it could safely come to a landing, and also landing on the back of a moving truck. So I learned a ton. That was an amazing project. But I also learned what was missing when you need to go from automation to autonomy. What is missing to integrate such an aircraft into the airspace system? How do you make sure that you don't run into other airplanes? How do you avoid obstacles and things like that? So that was the premise before I got to Xwing.
Maxime, thank you for sharing that fascinating background, and it really does set the stage for what you're doing now with Xwing. So please, for anyone not familiar with Xwing, tell us all about the business, who you are, what you do, the mission of the organization, and then we'll jump into talking about the role that technology plays behind the scenes.
So Xwing, we started in 2016, and the mission of the company is really to change how people and goods move for regional distances, so 100 to a few hundred miles. If you look at the transportation landscape, for short distances, you can take your car, take a bus, take the metro, and that's very efficient. If you need to travel long distances, you can take the commercial flight, and we can complain about TSA, but overall, the experience is quite amazing. But if you have to go 100 to 500 miles, you don't have a choice. You have to drive, and these are really long times to drive. When we looked at this landscape, okay, this is a part that can be improved. And the best way to change that is to have small airplanes that are autonomous and eventually will be clean, because we want to decarbonize the industry. But really the key enabler here is the autonomy. You don't want to have a pilot. If you have a pilot, it's going to be too expensive, too difficult to get those pilots. So we are focused on making small aviation autonomous and remotely operated.
This is obviously a topic which is now becoming more and more popular with the introduction of autopilot within cars. And obviously all the data shows that it's safer and overall the way to move. What you're trying to do is a lot more challenging because of the complexity of fully automated flight. Can you give us some insight into, from the the original concept and the previous experience that you've got, what were the early steps that you guys had to take to come up with a proof of concept to get some initial buy-in? And what's the journey been like over the past 4 or 5 years?
The automation portion, like making the airplane fly itself, it's actually nothing new. The first autopilot was 1915 when the cars were in their infancy and the airplanes also, but we already had autopilots. So the automation of the aircraft is something that is really well understood. But the portion that are the key novelty is really being able to integrate it to the airspace, meaning that you need to be able to detect other airplanes that are around, detect any hazard. So an obstacle on the runway, an animal when you're taxiing, an animal crossing, the weather around you, and being able to safely reconfigure your trajectory. When you fly, you don't have the luxury of stopping if something goes wrong, right? You cannot have any failure that causes the airplane to stop. So focusing on this perception and decision-making is one of the novelties. And then the other portion that we have to work on is interfacing with air traffic control. Air traffic control is in charge of a lot of the airspace. And when they tell you to do something, you have to do what they tell you to do. So we need to have a way to interface with air traffic control to be able to safely navigate the airspace.
Focusing then specifically on the use of AI, whether it's computer vision, machine learning, or automation of processes. As the CTO, you obviously sit at the head table and you oversee all of the technology behind this. Can you give us some insight into how you and the team at Xwing utilize AI, whether it's a combination of analytics, machine learning, but what's it like behind the scenes? What's it like to be part of the technology?
So on the flight controls portion, the portion that makes the aircraft fly itself, we use traditional methods, mathematically proven methods, because they work really well and that's efficient. When you get into the perception stack, that's where we use more of those AI machine learning based techniques. So we use a lot of radar data, computer vision. So we collect all the data, we train the models to recognize the objects around, and the objects may be obstacles on the runway, maybe airplanes, maybe the runway itself that we can use for positioning. So it's a segregation of traditional methods, mathematically proven for the flight and maintaining the aircraft in the air, and for the hazard avoidance and some of the localization, that's when we use more AI-driven techniques.
You are listening to the Alldus podcast. When you're looking to scale your team, or if you are interested in showcasing your company in a future episode, reach out today. Or if you're in the market for a new role, visit our website to view open positions, www.alldus.com.
Maxime, obviously you've been with Xwing since the very beginning, and it's been an interesting journey to say the least, but you guys are making some incredible progress. When you look at what's next, whether it's in the next year to 2 years, what are some of the major milestones that you're working towards and some of the challenges that you're going to face along the way?
So over the past few years, we've done a lot of development, lots of flights. We have retrofitted aircraft that can taxi, take off, navigate, land, and even avoid like obstacles in the air. And all of that at a prototype level. So the goal was really to understand what are the requirements, what are the problems we have to solve, prototype some solutions. And now we're in the phase where we need to move on to certification, meaning that for an aircraft to be able to fly commercially, it has to be certified by the FAAs. They have to look at everything you've done, all the processes you followed, your code, and making sure the airplane is safe to have people, to fly over people, and eventually to have people on board. So we're in this very interesting phase of transition to go from prototype to a certification. So it's about getting the hardware that can be certified, updating our software to also go through the certification process, and going, to all the corner cases. And when you prototype, you want the 80%. Now it's time to go to the 100% and make sure that the software can really perform in all types of conditions, that we don't have any failure modes, and so on and so forth. So we have we're going to keep on doing some demonstration, keep on pushing the product and going towards certifying that software and hardware stack.
When do you see this technology being a reality? When can we expect to see, whether it's commercial or industrial airlines, flying fully automated with maybe some supervision from human in the loop? How soon is this to being a reality?
So we are already doing some of those flights, right, where the aircraft is flying on its own, supervised by an onboard pilot at this stage. So this is a reality. Then the next step for us is going to be removing the safety pilot by having the right level of redundancy on board the aircraft, and as I mentioned, certifying it. And our target for certification, late 2024. So at that point, that allows us to fly commercially without any restrictions. In the meantime, we're going to keep on working with the FAA and our partners to have demonstration flights to really show what the technology can do.
Very exciting. So close is what you're saying.
Yes.
That's so cool. Maxime, I want to spend a bit more time now talking about the team at Xwing, the culture, and obviously with the continued success and as more of these demos go, you guys are going to need to grow. So could you give us some insight into what it's like to be part of the team there day to day? And as you continue to grow, what opportunities are there going to be for people to come and join Xwing?
Yeah, so the team has been quite amazing in the achievement, given the number of people we have. So really high quality team with a really wide array of backgrounds. If you think about what it takes to make an airplane fly, you're going to have some electrical engineers, some mechanical engineers, some systems engineers, some flight test pilot, flight test engineers, lots of software. Across the stack, going from embedded software to user interface for our ground control stations to the data management, because we collect like a ton of data during all these flights. So there's a wide variety of skill sets on the software side that are required. So we've been hiring quite a bit across the board, and we will keep on doing so. And when you think about the day-to-day life at Xwing, we are structured in an agile where we set ourselves with relatively shorter milestones, things to achieve, so that the team makes the progress, updates their software, their hardware. We go flight test, so lots of flight testing, data analysis after that, and rinse and repeat, and make some good progress. So it's quite amazing to work in an environment where we work in the hangar where you have the airplane, and you get to see and touch your product, which is amazing. And I think when you write software that does something on the cloud, I feel that's fun, but it's not the same as when you put your software on the airplane, you sit on the airplane and the airplane start doing what you asked it to do, right? Having this physical connection between the software and the hardware is just amazing to me.
Completely agree. Final question for me then, Maxime. When you look at the journey of Xwing to date, from concepts to flights in the air, the progress you guys have made is staggering. When you look ahead for the next few years, what are you most excited about? What are you really looking forward to as the next phase of Xwing's growth?
I'm really excited about seeing all the hard work that we've put into it go from a demonstrator to a product, making commercial flights where we can make an impact. As I was describing earlier, one of the premises of the company is to have this impact on people. So they have a lot of communities that are really far away from other people. They don't have access to fresh goods, to even vaccines or to medication. So by having those flights, those regular flights, you really bring together those communities that very often feel isolated. So I'm really excited about seeing how we can impact those communities, how we can change people's life by bringing them what they really need.
Maxime, thank you so much for coming on today and talking to us. Xwing is an incredibly exciting company, and what you guys have done is truly remarkable. Really appreciate you sharing the details behind the company's journey and just how close this is to being a reality. It sounds like it would be a fun place to work. So thank you again for your time, and good luck with everything in the years ahead. We really appreciate it.
Thank you, JP, for the time. It was fun being on the podcast.
Thanks for listening to this episode of the Alldus podcast. If you enjoyed today's episode, don't forget to subscribe, rate, and review. We are available on Apple Podcasts, Spotify, and any Android podcast of choice. You can also head over to our website, www.alldus.com, to listen to more podcasts, view our open roles, and stay up to date with industry news. Thanks for listening, and stay tuned for more great episodes coming very soon.